And finally, in this episode, we are going to be talking about sulfur. Now, sulfur is a special element on the periodic table. It's the 16th element on the periodic table, and I'll be drawing the electronic configuration of sulfur in two different ways. So, if you have to draw the electronic configuration of an element, there are two different ways of doing that. So, this is the sulfur. This S, this is symbol for sulfur. It is S, and then you have 32. It has a mass number of 31. It has an atomic number of 16. Now this sulfur, I can draw it in terms of the electron shells. So and then I'll start from the nucleus. This is the nucleus, the dense nucleus. Then I'll talk about the K shell. So the K shell is the first shell outside the nucleus, and it consists of two electrons, 1, 2. Outside the K shell, you have the L shell. The L shell is outside the K shell, and this L shell contains of 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now when you have done that, and your total is 16, right? So when we add 2 plus 8, we have 10, remaining 6. So that means those 6 will be contained in the M shell. Outside the L shell, we have the M shell. So this M shell will have 6 electrons. 1, 2, 3, 4, 5, 6. So that is the electronic configuration of sulfur according to the electron shells. And then you can also draw the electronic configuration according to the electron orbitals and the basically in terms of the subshells or the suborbitals. Now that's when you make use of your 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, and so on and so forth. So it goes down to the lowest. So and then basically make use of your arrows for drawing the how they would be. So for this one, we don't need more than the first 4 arrows. So and basically you begin to assign the electrons. So basically now we have to know the maximum number of electrons in each of these blocks. So for this S block, we know that it is 2. For the P block, we know that it is 6. For the D block, we know that it is 10, and for the F block, we know that it is 14. So we'll now begin to list them in order of their energy. So this 1s is the block that has the lowest energy. That's 1s. Then this 2s is the orbital that has the next lowest. That's 1s, 2s. We have 2p. We have 3s. We have 3p. After 3p we have 4s, because 4s has lower energy than 3d. After 4s we have 3d. So for now, this is just what we need. In fact, we won't need up to d because sulfur is not a transition element. So it's only transition elements that you can see d orbitals, and then it's only the actinides and lanthanides that have the f orbitals. So for our normal non-metals and metals, we often involve only your s and your p orbitals. So moving on, now we begin to fill these electrons according to these rules. Now the first one we have is this 1s. Now for this s block, we have only 2 electrons, right? So we'll put that 2 as a superscript on top. Then we'll go to the 2s. For this another s block, it contains only 2 electrons. That's 2. So you must keeping track of the remaining electrons you have. So and then after this s electrons, we have the p electrons, and then these p electrons, we have p electrons have a maximum of 6. So let's put 6. Then after these p electrons, we have the 3s. So it also has 2. S block has 2. Then we have p again. P has 6. So but first, before we continue, let's check how many we have written. So we have 2 plus 2, that's 4. 4 plus 6, that's 10. 10 plus 6, sorry, 10 plus 2, that is 12. So and then we have a total of 16, but we've taken 12 already. So that means we have 4 left. So that means the last and the next electron suborbital we have of 4 here. So we'll clean the rest because they don't have any electrons. So this is the electronic configuration of sulfur according to the subatomic orbitals. So and then these are according to the electronic orbital, and this is subatomic orbitals. So there are different methods and there are different ways you can do. So as for you can also try doing looking for the electronic configuration of magnesium using the first method and the second method. So this is how to look for electronic configuration of a metal or any element. Thanks for watching.